Hello everyone, let us solve GATE 2010 questions. The first part we will solve as thermodynamics. In a homogeneous system with C as the number of components in equilibrium, the total number of independent intensive thermodynamic variables is. Okay, right? So please take care here. Here it is asking independent intensive thermodynamic variable, right? So that we call it as degree of freedom also. So guys, we know F, right? The formula is F equal to C minus P plus 2, right? And what is the number of component here? It is C, okay, in equilibrium. And this is a homogeneous system, right? So it does not talk about the different types of phases which is there. It is just telling you that it is a homogeneous system, right? So the minimum amount of phase which can be 1, right? And since this is a homogeneous, it has only talked of homogeneous, so the number of phase will be here 1. So right, so what is the value of F? It will be C minus 1 plus 2, that means C plus 1, right? So the correct answer is C plus 1. Next one, which of these metals cannot be electroplated from aqueous electrolyte, right? So the question here, it is asking that which among these elements, these metals, cannot be electroplated, right? So guys, what is the mechanism of electroplating? Mechanism is that there is an electrolyte and we have something called as cathode and something called as anode, right? So now suppose we assume it as anode and let us assume it as cathode. So the deposition of ions takes place from this electrolyte to this cathode, right? So at the cathode the reduction reaction takes place, means gain of electron happens, right? Now guys, see here that these elements like Al, copper, nickel and zinc, right? Now if we know the reduction potential of these elements, right? So what is this reduction potential? Reduction potential we write here, right? This is the form, okay. So what does it tell? Now if suppose reduction potential is negative, okay, if it tells that reduction potential is negative, that means this reaction, means the tendency of reduction is low. That means what is the tendency? The tendency of oxidation is high, right? So that means the reverse reaction will happen predominantly, right? So that will be more favored, right? So now for the deposition purpose we need to add this ion Mn plus, right? And there will be electron flow, right? This will be like this, okay, because electron will come from this and this ion will get attracted over here and it will form this deposition. But since here it is, if it is a very high negative, reduction potential very high negative, that means this reaction will not be favored. So can we see among these which element has the higher negative of this electrode potential? So if you see the electrochemical series, then you'll find that aluminum has more negative. So what is the reaction which will it prefer, right? So it will prefer, like aluminum want to break into Al3 plus 3 electron, rather than the reaction Al3 plus 3 electron to form this Al, which will ultimately helps in deposition, right? So that's why here aluminum will be the correct answer, right? Okay. At a steady state and when the inner and outer walls of a long hollow cylinder are kept at two different temperatures, the unidirectional temperature variation along the thickness of the wall is, okay. Now So this is a hollow cylinder, right? Now suppose this is a case of hollow cylinder. Okay, so this is your inner radius and this is your outer radius, and these two are at different temperature like T1 and T2. Okay, the unidirectional temperature variation along the thickness of the wall. So what is the temperature variation along this wall? So how this temperature vary? So that variation of temperature we can predict from the equation which tells you the rate of heat flow through this surface. So what is the equation for that? We know for a cylinder it is Q is equal to like T1 minus T2, and suppose here radius is R1 and radius is R2. So here ln R2 by R1, then 2 pi K into length of this cylinder be L. Okay guys, so can we again write this T1 minus T2 as Q into ln R2 by R1 2 pi KL. So this temperature variation we can say is directly proportional to, because this K and L are constant. Okay, so we can say this change in temperature is directly proportional to logarithmic of this radius, the radius ratio basically. So that means the temperature variation will also be like a logarithmic, right? So that's why the logarithmic will be the correct one. Okay, no problem. Okay, so this is for the cylinder. Now suppose the question would have been asked for a normal plane wall. So we know this Q is equal to minus, sorry, we can write it as this. I am discussing for wall as like plane wall. Okay, so Q is equal to T1 minus T2 by L by Ka. So from here this T1 minus T2 is equal to Q L by Ka. That means it is directly proportional to length. That means it is very linear. So here it will be linear in the case of plane wall. Okay, but in the case of cylinder, which has been asked in the question, so it will be logarithmic. Okay, fine. Next, which of the following partial derivative is equal to del S by delta P at constant temperature T? Okay, so among these, which is the correct one, right? So guys, for this you will have to remember the Maxwell equation, right? And it is very likely that in the examination you will not be able to recognize quickly like what is the Maxwell equation which we can use here. So one of the trick is you should remember all the equation and accordingly you can apply, right? Okay, so now I will write all the equations for you, right? We know du is equal to TdS minus P dV, then dH equal to TdS plus VdP. It changes here, VdP. Then this dA is equal to minus SDT minus PdV, and dG equal to minus SDT plus VdP. These are four Maxwell equation, and guys you need to remember it. You can follow some trick also to remember it. Like I have followed one trick, maybe it may be beneficial for you, I'm not sure, but you can follow like this, which I want to state. You can skip it also or you can keep it also, right? Okay, so like first, like you will have internal energy, right? It starts with internal energy first. So like du, like TdS, so TdS is equivalent to TCS, like TCS company, right? And PdV means private, means TCS is a private company, right? I have remembered like this. It is like TdS minus PdV, the first thing which I have remembered. So after this internal energy, we'll use this enthalpy concept. So it will be like dH. The first thing remains constant, so TdS, and the second thing will change here with negative sign. So negative is already here, so it will be positive, and it will change like VdP. Okay. Next we'll follow from the basic, like it will be like Helmholtz free energy. Okay, so now in the next case what we will change the first one, right? Because in these two, these were constant. In the next case we are going to change this, so you will change with a negative sign, so minus s dt. So this dA and du will follow the same trend in this second part, so it will be like minus p dv. Then next is dg, so it will be like first one, it will be same, because for dA dg it will be same, so minus s dt plus vdp. This is the trick which I have followed. Okay, now guys, you see, to find this, to calculate this delta S by delta P at constant temperature, right? So now you see which equation will be favorable here, because you will have to see whenever a term like any equation if you take, right? So if you see here, like delta S by delta P at constant temperature, right? So to do that, you will have to find this entropy first. That should be independent, that should not be in a differential form. Then this delta P should come from the one part of the equation, right? And this constant of t will come from the first part, from where this S was independent of differential. So now if you see this equation, dg equal to minus s dt plus vdp. So you see S is non-differential, okay, and this dp will come from this location, fine, and the constant term will be from the first term. So here it is dt, so here yes, we can write a constant term over here, right? So there is no issue over here. Okay, so this is just like m dx plus n dy is equal to 0, right? So we write it now like delta m by delta y. So m will be differentiated with this differential term in the next case, right? So this will be equal to delta n by delta y. Okay, so here we'll keep x as constant, and here we will keep y as constant, right? So here it will we'll write at right here as del s by del p at constant t with negative sign, that will be equal to del v by delta t. See, v will be differentiated with this delta t, fine, and what will be the constant? Pressure will be constant, right? In the question here it is asking to delta s by delta p a constant, so this negative sign can be taken in the right hand side, so it will be minus delta v by delta t constant pressure, right? Okay, so which one is the correct option? Delta v by delta t constant pressure, yeah, so option A. Okay, so option A, it matches. Okay, next question. Two fluids, okay, two fluids of densities rho 1 and rho 2 are, these are like rho 1 and rho 2, okay, are flowing at velocities v1 and v2, okay, respectively, through smooth pipe of identical diameter and pressure per unit length. When the friction factor is same, the ratio of rho 1 to rho 2, here it is rho 2, okay, is equal to, okay. So guys, the given thing is that the diameter is same and pressure per unit length is same, and the friction factor is also same, right? So there is a equation which relates the pressure drop per unit length in terms of friction factor and this density and velocity, okay. So that equation is like delta P by L is equal to friction factor, then rho V square by D. Okay, D is the diameter and density, velocity, right? So this Fd is some kind of a constant term, right? So we know for the first pipe, let it be like Fd for the first rho 1 v1 square and d1, and we know d1 and d2 are equal, so we can write here d, and Fd also we can write same, right? Delta P by L also we can write same, right? So for the second case also let us write, so it will be Fd rho 2 v2 square by d. So these two are equal, right? So we can directly divide these two, so it will be like rho 1 v1 square is equal to rho 2 v2 square. So this rho 1 by rho 2 is equal to v2 by v1 square. Okay, so this corresponds to option C. Okay, fine. Now let us solve 2 marks question. In a binary system, the difference in chemical potential of two components mu minus mu j is equal to, okay, so the first component here it is written like mu, so I will write it here as mu I. Okay, first component, let it be I and j. Okay, so here now see, if you know the rule of mixture kind of concept, so from there we know this G is equal to x of I, right? It will be x of I mu of I plus x of j and mu of j, right? So once we differentiate it, then it will be dg equal to mu I dxi plus mu j dxj, right? And the other terms will be taken as 0. Okay, fine. Now guys, we also know xi plus xj is equal to 1, so this implies dxi dxy is equal to minus dxj. So we can write here dg equal to, so see in the answer it is in terms of dxj, so we'll write dxi is equal to minus dxz. Okay, so mu I, so minus dxj plus mu j dxj. So this dg we can write it as mu j minus mu I dxj. So this dg by dxj is equal to mu j minus mu I. So this implies mu I minus mu j is equal to minus of del g by del x, right? Or minus dg m it is called as by dxj, right? So it will be option D. Okay, fine. Next question. The temperature of a gas flowing in a long duct as measured by a thermocouple, okay, having emissivity of 0.5 is 800 Kelvin. The internal wall surface of the duct is at temperature of 500 Kelvin. Okay, the connective heat transfer coefficient between the gas and the tip of the thermocouple is 100 watt meter. Okay, the actual gas temperature is approximately, right? So see here, it is a very interesting question. Now see, there is a duct, like there is some kind of duct. Okay, so once we have a duct, so some gas is flowing, and this gas has some certain temperature T, which we need to find the actual temperature. And what this thermocouple is showing is because of this losses which is happening over there, because some heat is being lost, so that's why it is showing another temperature that is just getting maintained after this compensation of this loss. Okay, so let this temperature of this gas be Tg. Now guys, suppose there is a thermocouple which is attached over here. Okay, so a thermocouple is attached, right, like this. So this thermocouple has some certain area, let it be area as A, fine. Now, so this tip of this thermocouple portion shows the temperature of 800 Kelvin. So the temperature here it is 800 Kelvin, which is being shown after the loss. So now how the heat is getting transferred? See, the gas is transferring heat to this thermocouple wire through convection method, right? So what is the amount of heat which is getting transferred? It is H into A into delta T. So what is this delta T? Here Tg minus 800 Kelvin, right? Because at the tip it is showing 800 Kelvin. Okay, that should be equal to, see, because heat mechanism is like heat is flowing from here, and because this portion is temperature, this portion is at temperature of 800 Kelvin, and this portion is connected to this wall, right, the internal wall surface of the duct, it is in contact over here. So here the temperature is 500 Kelvin. So there is a temperature difference. Even if the temperature difference would not have been, so there, since it has some emissivity, and emissivity value it is given 0.5, so due to this radiation the heat will loss. Now what is the amount of heat loss it will happen? So it will be like sigma A, and here epsilon is the emissivity, sigma epsilon sigma A, and T, that is which is over here. So T which is over here is 800, right? So 800 to the power 4, 800 to the power 4 minus, what is the T at B, right? So here TA TB, so it will be like TA to the power 4 minus TB to the power 4. So TB is 500 to the power 4, right? So now we have all the values, so put over here. So it is 100, and this area and area will be constant, right? So 100 into Tg, which we have to find, minus 800 is equal to 0.5, and this sigma value, right? So that is Stephen Boltzmann constant. So it is, I also forgot, yeah, it is 5.67 into 10 power minus 8, okay, into this 800 to the power 4 minus 500 to the power 4. So guys, do this calculation. So it is 3.471 into 10 power 11. Okay, so this implies 100 Tg minus 800 is equal to 898.40 Kelvin. So 898, that means it is close to 900 Kelvin. Okay, so this is the correct answer. Okay guys, hope This will clear your doubt. Next question. Yeah, see. The difference in reversible potential between oxygen reduction and hydrogen evolution reaction at any pH. It is at any pH, okay? In an aqueous electrolyte is given a standard reduction potential for hydrogen evolution reaction. That is E naught for 2H plus. So here guys it is like 2H plus over here. 2H plus giving you H2. So it is 0. So electrode potential is 0. Okay. And oxygen reduction reaction is E naught O2, right? So here it is O2 giving you 4OH minus, that has got 0.4 volt. And also the partial pressure of H2 and partial pressure of O2 is 180. So what is the value? Okay. So what is this potential between oxygen reduction and hydrogen evolution reaction? So what is basically the potential for this complete reaction? So this is very simple question, but it has been asked in a different way, right? So first you will have to predict what is the reaction which is going to happen, right? So the first reaction is like hydrogen evolution. Okay, so we can write it here, hydrogen evolution, right? So like, okay, the first reaction we can write it here, and the second one is the reduction reaction which is happening of this O2. So here O2 plus, like, since in the product we have OH, so there has to be H2O which is getting involved over here, and here 4 times of OH minus, that means 4 electron will be involved here, will give you 4 OH minus. So how you will have to balance it? So now you can see this will be the reaction, right? And the electrode potential of this, so it is like reduction is taking place, so it will be like cathode is equal to 0.4, and this will be like anode, right? So here 2 electrons is there, so we can multiply this one as 2, so we can again write it. So like it will be 2H2 is giving you 4H plus 4 electron, and this E of anode is equal to 0. Fine. So we know E of cell, right? Okay, here it is asking the potential, it is just asking the reversible potential, it is not asking for the just equilibrium potential. So you will have to use E cell is equal to E naught cell minus 0.059 by n. What is the number of electrons? So here it is 4 log, see. So first we'll have to combine these two equations, right? So let us combine these two equations. So it will be O2 plus 2H2O plus 2H2 is equal to 4H plus 4OH minus. Okay guys, so it will be H plus to the power 4, OH minus to the power 4 divided by partial pressure of O2 into partial pressure of H2, and activity of water will be taken as 1. Okay, and guys here see pH2 and PO2 is equal to 1, so it will be equal to 1, so we can neglect this. So E naught cell will be how much? E naught cell, we will simply add these two, so it will be 0.4 minus 0.059 by 4. So here we can write it here as, see, here it is like H plus to the power 4, OH minus to the power 4. So we can write it here like log H plus into OH minus is complete to the power 4, and this 4 we can take it out, so you can write like this. And guys, since here it is asking for any pH, right? So now see, we have a product of H plus and OH minus concentration, and we know that H plus into OH minus is equal to 10 power minus 14. It is always true. So we can write here 0 0.4 minus 0 0.059, and so it will be log 10 power minus 14. So this 10 power minus 14, so we can take minus 14 out, right? So it will be like 0 0.4 minus 0 0.059 into minus 14. So now if you do this calculation, so let me do this. So 1.226 volt. So this is the answer. So 1.226, that means 1.23. Okay guys, now let us proceed. This is a statement linked question, because so this statement will be used for the other equation, which is other question which is coming just next. So at 1200 degrees centigrade, the standard gives energy of thermal decomposition of 1 mole of oosterite into FeNO2 is 168 kilojoule. The corresponding dissociation pressure is. So what is that dissociation pressure? So from where this pressure will come? This pressure will come from reaction itself. Let us see what are the reactions. Some gaseous component is there or not. So see here, the decomposition of oosterite. Oosterite, we know it is FeO. So now if you decompose it, like after heating, so it will form Fe and O2, right? So O2 it will form. So now to balance this, we can write it as half O. And this reaction energy delta E, it is, yeah, this delta G is given as 168 kilojoule. Fine. So now guys, we know delta G is equal to minus of RT ln K. Okay, fine. So this delta G, basically it is G naught. So delta G naught is equal to minus RT ln K. Right? So here it is given, the standard gives energy. So we will write here delta G naught. Okay. So this implies delta G naught, you know, it is 168 into 10 power 3. So it will be minus 8.314 into T. T is 1200 degrees centigrade, but we will have to change it into Kelvin. So 1200 plus 273 to ln K. K is how much? It will be partial pressure of O2 to the power half. And rest activity of iron and activity of Fe1 can be taken as 1, because these are solids. So 1, it will be 1. Fine. So see here, the partial pressure of oxygen is coming. That means the whole dissociation pressure will depend on this partial pressure of O2, right? So guys, now if you do the calculation, I have done it. Okay, so I have done it. So I will just write this calculation. So it was like minus 13.718 is equal to ln PO2 to power half. This implies PO2 is equal to e to the power minus 27.43. That is equal to 1.22 into 10 power minus 12. Okay, so this is your answer. Okay, so the answer is 1.22 into 10 power minus 12. Okay, so there is a mistake which is in the option. So actually the B option was 1.22 into 10 power minus 12, and the C option was 5.00 into 10 power minus 8. So it was by mistake written top and bottom. Okay, so it will be option B. Now see next question. Given for the reaction 2CO plus O2 is equal to 2CO2, the standard Gibbs energy is minus 310 kilojoule. What is the equivalent PCO by PCO2? Okay, this is also related to similar question which we solve, right? So this we can write 2CO plus O2 is equal to 2CO2, right? So we can write here delta G naught equal to minus of RT ln K. So again we can write it as minus RT ln K. Ke will be partial pressure of CO2 whole square, then partial pressure of CO whole square, then partial pressure of O2, and delta G naught equal to minus 310 to power 3, delta will equal to minus 8.314, and temperature is again 1200, which we will take from the previous one. So it will be 1473 to ln PCO2 by PCO whole square 1 by PO2. We can take like this. Okay, so now you need to just do the calculation. So now, so here you can write it here like 25.31 is equal to ln PCO2 by PCO whole square 1 by PO2. We can write it as ln PCO by PCO2, sorry, PCO2 by PCO whole square minus ln PO2, right? Fine. So this we can write again as 25.31 okay, I've done the calculation. So here it will be minus 2.122 is equal to 2 times of ln PCO2 by PCO, right? So now we can again do some calculation, and it will be 1.06 equal to ln. We can reverse this, right? PCO by PCO2. This PCO by PCO2 will be equal to e power 1.06. So it will be equal to 2.88. Okay. So these were all the questions of thermodynamics. Hope this will help you for your preparation of GATE. Thank you all.